Hello and welcome to Math on the Go. Today we're going to use the definition of a derivative to solve a function to find its derivative. So the definition of a derivative is f prime of x equals the limit of h to 0 f of x plus h minus f of x all over h. We will solve the function f of x equals x squared plus 2x minus 1 using the definition of derivative. So what we're going to do is this f of x plus h is wherever there's an x, we're going to put in x plus h. So x squared would be x plus h in parentheses squared. So we'll go ahead and do that. So we have x plus h squared plus 2x plus h minus 1. And then f of x is just going to be this. But I'm going to put it in parentheses, x squared plus 2x minus 1. And all of this is over h. Now, we're going to expand this x plus h squared to give us x squared plus 2hx plus h squared. Then we're going to distribute this 2, so we have plus 2x and plus 2h and minus 1. And then we're going to distribute this negative sign. So we have negative x squared minus 2x plus 1, and all of this over h. Now the next step that we're going to do here is we're just going to find what we can cancel. So we have a positive x squared and negative x squared, so they can be canceled out. Then we have, let's see, positive 2x and a negative 2x, negative 1 plus 1. And I think that's it. So what we're left with is 2hx plus h squared plus 2h all over h. And then what we're going to do is we're going to pull an h, because there's an h in each term here, so we're going to pull an h out in front. So we're left with 2x plus h plus 2 over h. Now we got an h in the numerator and the denominator, so we can cancel our h's. So that leaves us with 2x plus h plus 2. Now, this h right here, that's h goes to 0. So we substitute 0 in for h. So we have 2x plus 0 plus 2, which equals 2x plus 2. And then we can simplify this by pulling the 2 out again. So we have 2, and in parentheses, we have x plus 1. And that is our derivative using the definition of derivative. All right, let's move on to something a little more difficult here. This time we're going to do a derivative with a square root. We're going to find the derivative of f of x equals the square root of 4x minus 9. And we're going to use the same definition, f prime of x equals the limit of h to 0, f of x plus h minus f of x over h. So, again, we're going to put x plus h in for anywhere there's an x. For the first f of x plus h, and then for the minus f of x, we're just going to put in the square root of f of x minus 9. So we're going to have, let's see, 4x plus h minus 9, that's the square root, minus 4x minus 9 square root over h. Now, we're going to distribute the 4. So we have 4x plus 4h minus 9 square root minus the square root of 4x minus 9, again, over h. Now what we're going to do here is we're going to rationalize the numerator. So I hope you remember from previous math classes that when you rationalize the numerator, you multiply both the numerator and the denominator by the numerator. But what we do is we change the sign. So we have this negative sign, that's going to become a positive sign. So this is what we'll have. We'll have multiplied by 4x plus 4h minus 9 square root plus the square root of 4x minus 9, and we'll have the same thing on in the denominator. So we'll have 4x plus 4h minus 9 plus the square root of 4x minus 9. So what that leaves us with, so we have a square root times a square root, which just gives us what's inside the square root. So we end up with 4x plus 4h minus 9. Then we have negative times a positive, so that's going to give us a negative minus 4x minus 9. Then on the bottom, we still have our h times what we have in the denominator. So we have the square root of 4x plus 4h minus 9 plus the square root of 4x minus 9. So what we can do here is we have 4x, a positive 4x, and that's going to be a negative 4x, so we can cancel that. Then we have negative 9, and then negative and a negative gives you a positive, so those will cancel. And that leaves us with just 4h on the top. So we have 4h all over all this stuff on the bottom. H times the square root of 4x plus 4h minus 9 plus the square root of 4x minus 9. So we have, in the denominator, we have an h, and in the numerator, we have an h, so those will cancel, leaving us with just a 4 on the top. So again, we're just going to rewrite this. We got 4 over the square root of 4x plus 4h minus 9 plus the square root of 4x minus 9. So what we're going to do now is we still have an h in the denominator, and h is being sent to 0. So what we have to do here is we have to evaluate the limit of h at 0. So if we were to put a 0 in for h here, that would just give us 4 times 0, which is 0. With this being 0, we know that cancels, leaving us with 4 over the square root of 4x minus 9 plus the square root of 4x minus 9. At this point, we got 4x minus 9 plus 4x minus 9, so that gives us 4 over 2 square roots of 4x minus 9. And we have a 2 in the denominator, a 4 in the numerator. So that cancels, leaving us a 2 on the top. So our final answer for our derivative is 2 over the square root of 4x minus 9. So that's how you use the definition of a derivative to find the derivative. This is just a good way to kind of see it visually of what's going on before learning further steps of how to do the derivative without going through all these steps. I mean, most of what we've done is just algebra. We just kind of substitute things in and solve it, just like in algebra. But in later videos, I'll be showing how to actually do derivatives the way you end up doing them further on in your calculus courses. So stay tuned for those videos. Thanks a lot for watching. Please like and subscribe. Donate money for coffee down in the description below if you enjoyed this video and want to see me do more. Any amount of donations helps, so thank you very much if you do. I hope you enjoyed, and I'll see you next time.